Hello everybody, thanks for joining to our new webinar. Today we will talk about the inside validation of your CASA and how you can incorporate it in the routine for your laboratories. So the first thing we would like to clarify is that the inside validation is something that should be carried out by the final users, not by the manufacturers. Okay, so the responsibility is from the final user. However, it's important to take in mind that you can account with the support of the manufacturer to get all that technical information that will be required to use during the validation process. So, the first thing that the user should do is just to check if there are any local regulatory guidelines that specify a list of requirements to accomplish for doing the validation. Okay, so for instance, in France, it's very frequently to follow the COFRA guidelines, in which there is a very detailed information about how to validate the analysis of semen samples in a laboratory. Okay, so you can use it as a guideline for doing your validation with your CASA. Also, you have the possibility to use international rulings like the ISO 23 that is specific for semen analysis, in which you will find the best practices to handle, to analyze the semen samples, and very important, to analyze all the sources of variations that you can find over the process of semen analysis. So, what is in common for all guidelines is just the necessity to check that the facilities, that the supplies and the equipment to be used for the validation is optimal, okay? And very important to check that the personnel involved in the validation process has the aptitude, has the qualification enough to run on a robust way all these tests. So, it's very important first to define what are the roles of the personnel involved in the validation, what are the minimum required to accomplish for each role, and then select the personnel that best fit to these requirements. Okay? So, once you get your team, it's important to create a protocol for validation. So, in that protocol, it's important just to define what are the tests to validate, what will be the role or the implication of each personnel on the different process to be carried out during the validation process, define the timing for the validation, the procedures and the criteria for assessing outcomes. Okay, this is important because normally people is directly running comparisons, manual, automatic comparisons, and then we will handle with the results. Okay, it's important just from the very beginning just to define what are the specific procedures for doing each test, what will be the criteria followed, and what will be the principles for approving this validation. Okay, what analysis should be excluded from the validation, how to handle these outliers. Okay, so all these points should be defined from the very beginning. So, in that protocol, it should be specified these standard operating procedures, okay, that will guarantee that the system, that the CASA is accomplishing with the claims of the device or just the intended use that is specified in the technical information of the system. Okay, so here is very important just to account with all this technical information from the manufacturer, to specify the protocols for doing the sample handling, sample preparation, how you are using the CASA, what are the steps. So here the flow charts included in the user manuals could be useful just to get an overview about what are the steps, how to run each test, decide if you want to add manual corrections, if it's not required to add manual corrections, and all these things that you consider that are important for specifying and for running all the tests on the same way during this validation and obviously during your routine. Also, it's important to define how the data is to be collected and how will be evaluated, and the test to be performed. specifically just defining what are the possible sources of variation that you can find on each step, okay, and what is the acceptance or the rejection criteria for each step. A very controversial point is just to define the minimum number of samples to be considered in the validation process. So most of the validations are assuming close to 30, 50 samples for assuming these, the results obtained as robust. Here what we need to consider is that we are reaching the minimum number of freedom degrees to do robust statistics, to get significant statistics. Okay, so it's important to just take in mind if you want to do groups, subgroups, what is the minimum number of samples to be included on each group or subgroup, okay, if you are reaching the minimum number of freedom degrees in order to get good statistics, okay. So it's very important to define what will be the statistics methods to be followed, okay. And what about how can we handle this deviation from expected conditions, or how to handle this non-conforming data? Okay, so what is very important is just once everything is well defined, this protocol should be checked by your quality manager or the quality responsible for the validation. Okay, so you should never carry on with the testing with real samples if this protocol has not been previously accepted by the quality responsible. So what are these critical points that could affect on my validation process? All these things that we should consider in order to minimize the sources of variation, or to do the comparisons more equivalent between automatic and manual methods. So the most important thing, and there is very basic, just to check that the system has been properly installed and calibrated. Okay, this is something very obvious, but is required to check that the system that is to be used for the validation has the warranty that is using according the manufacturer requirements. Okay, so just getting installation certificate, or just getting what are the calibration values in relation to a real measurement to prove that these measurements that the system is doing are realistic and accurate, it could be important just to get just to provide an evidence confirming the system is running as expected. Also, it's very important to get a good understanding about the use of the system. So I just recommend to do a training before doing the validation. Okay, here we can guarantee that the users are using the system as expected. Okay, so here is important just to know the limitation, to get a good understanding about the interpretation of results, how to handle some problems that could arise with CASA. Okay, so it's important to get a good knowledge about how to use, how to handle a CASA system. And very important to get a good knowledge about how to do a semen analysis. So here is important that all personnel involved in doing the test should follow an external quality program in order just to validate that has the aptitude to analyze as expected on a standard way these samples to be analyzed. Okay. Here, for instance, in MICROPTIC, we have developed an external quality control program just to check that our users are using the system as expected by the manufacturer. Okay, so this is important, for instance, to control that there are not so many manual modifications so that could reduce the objectivity and the standardization of the CASA. Also to check that the criteria for modifying the system, the results, are the same for all the technicians, okay? Unfortunately, there are not official external quality control programs for CASA systems. This is why at that moment we are just collaborating with the CAP, with the College of American Pathologists, and with Biologist Prospective in order to make compatible their external quality control solutions with our system and perform an official external quality control program for CASA. So also it's important just to do some bibliographic research about if there are other publications or other validations with the CASA you want to validate, okay? Here you can check the number of samples that has been used, what are the protocols or the statistics to be used. So here you can use it as a reference for defining your protocol and running your test. And a thing that is normally omitted during the validation, that is to perform a dry run with QC solution or QC preparation, okay? Just to control what is the variation between the manual assessment against your standard and the automatic assessment against the standard, okay? Here you can just verify that the personnel is really qualified for running the test and the system is measuring as expected for running its test, okay? So it's important to do a fast dry run with QC solutions and check what is the percentage of covariation or just what are the deviations from the expectations obtained with both methods. So especially when you are comparing manual against automatic methods, there are lots of sources of variations that could interfere on your results, okay? This is why we should do all this comparison as much as equivalent as possible, okay? So we should make comparable comparisons. It's not the same just to analyze a sperm motility at room temperature than at 37 degrees, okay? So despite you have the accreditation to run motility at room temperature, if you want to compare it against a CASA system that by default is working at 37 degrees, these results should never be compared because the conditions are not the same. The results are not comparable, okay? So you need to analyze under following the same criteria, okay? This is why it's important just to follow the gold standards like those provided by the ISO or by the WHO guidelines. Also, it's important just to control the disposables to be used during the testing, okay? So here we will do a specific emphasis on the how are you counting that cells, what are the type of counting chambers that are frequently used and what are the effects of these counting chambers, and what are the effects of the coloration on the comparisons. So when you are using counting chambers without grids, okay, that could be the slide and the cover, the LIJA, or these capillarity slides, you will need to just check manually what is the motility, the concentration on the chamber by using a grid, an APs with a specific grid in order to do a better accuracy, to get a better accuracy in the comparison between manual and automatic. You should minimize as much as possible all these sources of variation. That could be different aliquots, the use of non-proper pipettes. For instance, it's very common to use the conventional pipettes for loading chambers instead of the positive displacement pipettes that are recommended for handling semen samples. Here you can introduce a variation during the pipette. Also, depending on the width of the field to be analyzed on the microscope, you can introduce some sources of variation that at the end will be in charge of a high variation between manual and automatic results. Okay, so we should control as maximum all these variables. So for instance, if you are using this type of counting chamber without grid, you can just analyze the same field, okay, with this IP. Or for instance, when you are using CASA systems like the SCA or the SCA scope, there is the possibility to overlap a virtual grid on the same field that the system is automatically analyzing. Hence, you can just count how many cells there are inside that grid, or also you can play what is happening during 1 second and count how many progressive, non-progressive cells there are, okay, and just to get a real and accurate comparison between what is happening in your counting chamber in the field that you are observing by using the same aliquot, same disposable, same field, same time lapse. Okay, so here the comparisons are very robust and comparable. Okay. Also, another important thing to take in mind is just the effect of the counting chambers used for the manual and automatic assessment. It's very popular to use, for instance, for manual methods, the Mackler chamber, but then when you are using some CASA, it's better to work with a Lysia-like chamber or a capillarity-like chamber. Okay? By comparing these two counting chambers, the results will never fit. And this is not because you are not counting accurately or because the system is not counting accurately. This is because there is an effect of the counting chamber. Okay, here I have incorporated some publications that discuss a little bit about what is the effect of the different counting chambers on the sperm features, specifically for concentration. So here in that table there is summarized what are the results obtained when measuring a QC solution with different counting chambers. So for instance, on a QC solution with a concentration from about 23 million per milliliter, with a Mackler, it is obtained an average concentration close to 40 millions. This is close to twice the real volume, the real concentration of the sample. Okay. Conversely, with the capillarity slides, or maybe with the slide and the cover, these results are more accurate. But also it's important to take in mind not only the average result concerning concentration, also the variability between measurements. So as you can see here, for instance, when you are using slides or cover slides, these variations between measurements is twice or 3 times those that we are obtaining with capillarity slides. So it's very important to take in mind the effect of the counting chamber on the moment you need to select what is the disposable to be used in your routine and obviously in your validation. Okay, and just to check if it's comparable to compare one Mackler against, for instance, one Lysia or not. The differences between these chambers are partially explained by the SS effect. There is the Segre-Silverberg effect. This is an effect that explains that on capillarity slides, the distribution of the cells is not fully homogeneous over the chamber depending on the viscosity of the sample. Okay, so specifically when there are diluted samples, imagine that here there is a counting chamber and this is the loading area. Okay, so when you are loading a diluted sample, okay, from here, by Poiseuille effect, there is a natural movement of the cells to move and concentrate on a specific planes in which there is a fast flow of cells against the other part of the chamber, the opposite side of the chamber. These are the Segre-Silverberg planes. Okay, so this effect will result in the development of a meniscus in which it will be concentrated a higher number of cells than those that we can find on other parts of the counting chamber. Okay, so the concentration on the meniscus will be higher than those that we find on other parts of the counting chamber. So as you can see in this graph, when you are evaluating the Segre-Silverberg effect on a Liga chamber, most of the cells tend to move transversal to the flow, okay, of the chamber and concentrate on these SS planes that are like fast flow areas in which the particles are moving fast to the opposite side. Okay. Conversely, on the Neubauer chamber, improved Neubauer, despite the sample is spread by capillarity 2, in that chamber the huge depth of the chamber minimize at maximum this spread, this transversal movement of the cell through a specific planes. So the distribution of cells is practically homogeneous over the area of the counting chamber. This is why this is used as a gold standard for assessing sperm concentration, okay? Because it's very accurate and also the distribution of cells over the chamber is fully homogeneous. So when you are working with very liquid samples or diluted samples, we need to take in mind this effect. So when we are loading these capillarity counting chambers, we should expect that these cells will move laterally to these SS planes, will generate a meniscus, and most of the cells will be concentrated on this meniscus. So the concentration behind that meniscus will be below the expectation, the real concentration of the sample. And this is a problem. So how can we handle that? Leja manufacturer has performed a very nice study in which is related the time invested for filling the full chamber in relation to the viscosity of the sample. Okay, so depending of the time required for filling the chamber is required to apply a higher or a lower magnitude SS correction. Okay, you need to apply a correction factor to compensate this accumulation of cells on the meniscus. So just to summarize, when you are working with diluted samples, with very liquid samples, it is required to incorporate a correction factor from 1.23 to the concentration measured. It means that once you are using a CASA, for instance, and you get a concentration, you need to multiply that concentration per 123. Okay. Conversely, for viscous samples, this compensation is more moderate, and in so many cases it's not required to compensate. This is why in MICROPTIC CASA systems or for Hamilton-Thorne CASA system, we are assuming these SS corrections in the configuration settings in order that user could compensate and could control this effect on the capillarity counting chamber. Okay, so you can modify if required, and in order to get an accurate result, and the system will provide from the real concentration of the sample. Okay, this is specifically important when there are diluted samples. Another point important to take in mind is just the effect of the coloration to be used for assessing sperm morphology. Okay, there are so many publications that have revealed that depending of the osmolarity of the staining solution you are using, you are involving an artificial effect of the coloration on the abnormality report you can obtain. Okay, so you are introducing abnormalities that are not coming from the patient, are coming from the handling of samples. So when you are incubating your semen sample with an hyposmolar solution, like could be a Diffquick, for instance, what you are involving is the swelling of the head. Therefore, the morphometric parameters obtained for that sample stained with that coloration will be higher than the same sample that is incubated with an hyperosmolar solution, in which by osmotical processes the heads tend to shrink. This is important. Why? Because you can get different diagnostics depending on the coloration you are using, and it's important to standardize. What are your standards? What is the coloration to be used for your routine and obviously for your validation? Here, for instance, I have included that table that compares the different measurements obtained with Papa Nicolau, Diff-Quick, and Sperm Blue. Here you will see that with Papa Nicolau there is a tendency of shrinkage of the heads. With Diff-Quick there is a swelling. There are bigger length, bigger widths of the heads. Conversely, with Sperm Blue, this modification of in relation to the original sizes of the cells are practically non-considerate. Okay, so the results you are obtaining with the Sperm Blue, for instance, are more realistic, are more close to those obtained from a sample before staining. Okay, so it's important if you to take into account for first deciding what is the solution you want to incorporate in your routine, what are the possible effects on your sample, and just to take in mind for getting the diagnostic, for doing a good interpretation of the results. Okay, so finding macrocephalias with the Diff-Quick, it could be common if you are using that coloration, that swelling coloration. So you should be cautious with the interpretation of results, and obviously you should never compare one solution against another, because the results will be different and are not comparable. So once all your tests are done, you have run your samples, you get your results, it's important to think about what are the statistics that I have to do. This is something that you should previously define in the protocol. Okay, so what is frequently requested for the validation of CASA system is just to get the mean, standard deviation, and coefficients of variation on the samples, on the testing you have done. But it's important just to get a previous definitions from your acceptance and tolerances. Okay, so in that protocol, validation protocol, you should specify what is the tolerance, not after, in relation to the results obtained. Also could be interesting to check for the sensitivity, specificity and accuracy of the methods, taking into account the number of true positive, false negative, false positive, and true negative. Okay, here you can find the formulas for calculating each parameter. And is also requested in some cases to check for the linearity of the measurements. So here it could be important just to generate a bunch of multiple dilutions and check how your measurements are aligned to the expected concentration for each pool. Okay, so here you can just compare what is the linearity by using manual methods against the linearity by using automatic methods, or just to do a simple correlation between automatic and manual analysis. So once you have done your statistics, you have get your conclusions, it's important to incorporate all this information in a report, in a validation report. So here you need to summarize all the data you have included, all the statistics, the results, okay, including the non-conformances, all these deviations from the protocol and their possible effects on the validation process. You need to discuss what could be the origin, the reason of this unexpected observation, and just to discuss what is the criteria you have followed to accept or reject that unexpected observations, and obviously to get a conclusion with just specifying if the testing has been passed or failed. Okay, but this is a process that should be double check by your quality manager or quality responsible. Okay, in order this person could check that all the statistics obviously are properly done, everything is perfectly explained, argumented, and give the okay. So only until you don't receive the okay from the quality manager, you cannot assume this validation process as finished. Okay. Unfortunately, this is not the end of the story, because once you have validated the system and introduce it in your routine, it's important to give evidences about that the system is working as expected with the pass of time, that is the accomplishing with all the requirements that you have specified in your protocol, in your validation protocol, with the pass of time. Okay, so here is important to collect all this information concerning internal quality controls, just to run QC samples, just to check that results are not changing, to run annual external quality controls, just to check that the system is used and that is working as expected according its intent of use and all the expectations that are specified by the manufacturer. Okay, so you need to give evidences that the system is working as expected with the pass of time. So thanks a lot for your patience. Okay, and just to as a reminder, in our website you will find so many masterclasses about different topics. Okay, so if you want to know more about, for instance, quality controls, you will find a specific webinar on that, or about some specification about our disposables or something else. Also, you will find specific webinars on that website, on our website, and get more information and collect all this information in order just to get a better knowledge about the use of the system and what are the best disposables to be used for doing your routine. So thanks a lot. Now is your time for your questions.